In this lesson, we are going to learn how to graph quadratic equations. We're working in section 8.3. This lesson is actually broken up into 4 different videos. So lesson 1, you should have watched What Does A Do? Lesson 2, you should have watched Finding the Vertex. This is lesson 3, graphing quadratics. And then after you watch this video, you'll have a 4th video to watch, which is matching graphs with equations. So we're going to be working off of this handout here, graphing quadratics. And they're going to ask us to find the vertex, which we learned the formula for the vertex is negative b over 2a to find our x value. And then to find our y value, we plug in what we found for our x and plug it into all of them to find our y value. For what does A do, we're going to say whether our graph is going to be up or down. And we're also going to state whether it's going to be a wide graph, a narrow graph, or it's going to be the same as the graph f of x equals x squared. Then they're going to ask us to solve for x, which is we solve by factoring here. And then they're going to ask us to actually graph these functions. One other thing that we are going to add is I do want to make sure that we identify the y-intercept because we are going to use that in our graphing. So the very first thing we're going to do is we're going to find our vertex. So I'm going to identify the a, b, and c here. A is negative 1. B is 2, and C is 3. So negative B over 2A. When we work that out, that gives us the opposite of 2, which is negative 2. 2 times negative 1, which is also negative 2. And when you divide those two numbers together, that gives you a 1. So our very first value in our vertex is 1. And then to find the y value, we plug that solution into all of our x values. So you have to square this first. So 1 squared is 1. And bring down your negative. 2 times 1 is going to give us a 2. So this is negative 1 plus 2 is 1. 1 plus 3 is 4. So our vertex is 1, 4. For our what does A do, it's going to face down because our A is a negative, and it's going to be the same as the graph f of x equals x squared because it's a 1. I said that I did want to do the y-intercept. So the y-intercept is always your c value. So in this case, it's a negative 3. I'm sorry, positive 3. That's a plus 3. Sorry about that, guys. And then solving for x. So we need to solve this original equation they gave us by setting it equal to 0. So they gave us a little bit of a hard one. We never want to have our a value a negative, so we have to actually factor out a negative 1. This is called the greatest common factor. You should remember that. And so we're going to divide each of these terms by negative 1, which will end up changing all of their signs. So that becomes a positive x squared, and then a minus 2x, and then a minus 3. Now we factor what is inside of those sets of parentheses. So you would factor it using your AC method. So that would be x minus 3, x plus 1. You set them both equal to 0, and then you solve. So you get your answers for the solutions to be a 3 and a negative 1. And remember, those are our x-intercepts. That's where your graph is going to cross the x-axis. Okay? And then part D, they want us to actually graph this function. So there are two different ways that we can use to graph these functions. They can be used for many different scenarios. So if your problem can be factored, you can use those x-intercepts and your vertex to graph it. So for example, our vertex here was 1, 4. So when I go on my graph, you would go over +1 and up 4. And that is your vertex. And we have something that's called the axis of symmetry. It's this line, and I always draw it as a dotted line because you can't really see it once you graph your parabolas here. And again, the parabola is that U shape. Okay, so this was my vertex and this is my axis of symmetry. It kind of cuts your graph in half. So if we look at this right here, hopefully y'all can see this on the screen. Notice how we have cut this person's face in half. This would be the axis of symmetry because what they're stating is that hopefully everything on this side of her face is symmetrical, meaning the exact same as everything on this side of her face. So let's say that it's 3 inches from her ear to her nose. Well, hopefully, if everything's symmetrical, then it's going to be 3 inches from her nose to this ear. Okay, so we're going to use that here in just a minute. So, if we're using our x-intercepts, we would put a dot where x equals a +3. So at 1, 2, 3 on our x-axis, and where x equals a -1. Go -1, so 1 to the left. Okay? I'm going to make this a little bit darker so y'all can actually see that vertex. Okay, so now let's see if this was actually symmetrical. So let's count. From this, so the person's nose, to the ear, it would be 1, 2 spaces. So hopefully it'll be 2 spaces to the other one. 1, 2. So that means that this is symmetrical. We have done it correctly. So now we're going to want to curve our graph. So remember, your vertex is either your highest or your lowest point on your graph. So since it's going to be facing downwards, it's your highest point on your graph. Don't forget that you're going to have to curve these lines. Okay, so if you were to just do that, that graph means something completely different if it's just straight lines like that. So make sure that you do have a curvature to it and that you do include those arrows at the bottom. Okay, so the other way you could do it is by using your y-intercept and your vertex. Okay, so our vertex we would normally put right here, so it's a 1, 4, and then our y-intercept was at +3. So you start here and you would go up 3. 1, 2, 3. So imagine that all of this hot mess we just did isn't on there, okay? So all you have is your vertex and your y-intercept. Well, from this point, you would count to your axis of symmetry, which is 1 space. Notice that you only see, I'm trying to grab my highlighter. You see that you have 1 space in between there. Okay, so then for your next point, you would only have 1 space as well. So your other point would be here. Okay, so I kind of guessed it where the curvature would go, but that would let us know it would lie there. You're primarily going to use the factoring method when your problem can actually be factored. You're going to use the y-intercept method when you cannot factor it. Okay, so we're going to look at problem number 2. So this, you might not have any idea as to what we're doing still. That's okay. We're going to practice some more. Let's look at number 2. You've got x squared minus 4. So identify your A, B, and C. They want us to find the vertex. Okay? So your vertex is going to be negative B over 2A. There's no such thing as a negative 0, so we're just going to say 0 over 2, which is 0. And then we're going to plug that 0 into our original equation and then solve to give us a negative 4. Okay? So then we're going to say that our graph is going to be pointing up, and it's going to be the same since it's a positive 1 there. Our y-intercept is negative 4 because it's always the value without an x. And then they want us to solve for x. So to do the solutions, we would take our x squared minus 4, set it equal to 0, factor it. This is our difference of squares. And then set them both equal to 0 and solve. Okay, so those are our two solutions, negative 2 and positive 2. So let's look about using that y-intercept method first. So the first thing that you would do is to graph your vertex. That's always the first thing that you're going to do. So our vertex is at 0, negative 4. So when we get here, we're going to go 0 spaces left to right, and we're going to go down 4. And remember, through your vertex, you're always going to have that axis of symmetry. You can't really see it well because it's on this thick black line, but your axis of symmetry does go through that vertex. Now, if we were using the y-intercept method, we would then graph our y-intercept. But notice your y-intercept is at negative 4, which is the same as our vertex. That is a situation when you have to use this factoring method, and you have to use your x-intercepts because your y-intercept and your vertex are the same. So what we're going to do is plot our x-intercepts at positive 2 and at negative 2. And notice that they are both 2 places away from our axis of symmetry. So put some type of curvature to it for me. Put your arrows down. You're good to go. Okay. So now let's look at problem number 3. This is a good one where we could use, it should be able to use either method. So since we've seen the factoring one work a couple of times, we are going to use the y-intercept one here. So our vertex, we're going to find by identifying our A, B, and C first. A is a 1, B is a negative 2, C is a negative 8. So it's negative B over 2A. So the opposite of negative 2 is a positive 2. 2 times 1 is 2. And when you divide those numbers, you get a positive 1. Then we plug that 1 in place of our equation. So 1 squared is 1. Negative 2 times 1 is negative 2. Bring down your negative 8. So 1 minus 2 is negative 1. And negative 1 minus 8 is negative 9. So our vertex is 1, negative 9. And then they ask us to state what does A do. Our graph is going to be facing up, and it's going to be the same as the graph f of x equals x squared because it's an understood 1. And then we're going to tell them the y-intercept, which will be a negative 8. And then the x-intercepts. So x squared minus 2x minus 8 equals 0. You're going to factor that to get x minus 4, x plus 2, and then set them both equal to 0. So for your x-intercepts, you should get a positive 4 and a negative 2. So I said this time we're going to use that y-intercept method where we're going to use that counting. So the very first thing you should do is to graph your vertex. That is step 1. So your vertex is 1, negative 9. So you start here at the origin, you go over 1 to the right, and you go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you put your dot. Okay? That is where your axis of symmetry lies. Okay? Then your next step, so step 1 is your vertex, graph it, and the axis of symmetry. Then your step 2 is going to be to graph your y-intercept. Step 3 is going to be to count. Okay? So your y-intercept was negative 8. So we go on our y-axis until we get to negative 8. 1, 2, 3, 4, 5, 6, 7, 8. We put our dot there. Okay, so let's bring back this lady here. Okay, so we had the axis of symmetry that we just drew through 1, negative 9. And then we just drew our y-intercept, which was negative 8, somewhere around here. So we want to count and see how many spaces it would be to get from here to here. So for symmetric reasons, we're going to count the same number of spaces to go from here to here. So it's at the same spot. So we're going to count, and notice that it's one space from your y-intercept to your axis of symmetry. So it should be just one space to go from your axis of symmetry to your next point. Okay? So they're both one space away, and that's your graph. Okay? Now I would still need to do the arrows, but I'm also going to show you on this problem how we could do it by using those x-intercepts. Okay? So we would still do the vertex first, and then our x-intercepts are positive 4. So 1, 2, 3, 4. We were close. And then a negative 2. 1, 2. So I was going a little bit wider. And that's how we would have done it using the x-intercepts. So you might feel that the x-intercept way is easier, or you might feel that the counting is easier. I really don't care which method you use. But sometimes you're going to have to use one method, and sometimes you're going to have to use the other. It just depends on which one works. Number 4, we're actually not going to be able to graph number 4 just because the numbers are too large. However, we are still going to work it out. So your vertex, first going to find your A, B, and C. A is negative 2, B is 24, C is negative 70. So it's negative B over 2A, which gives you negative 24 over negative 4, which is a positive 6. And then we plug it back in to our original equation. So 6 squared is, 36. And then negative 2 times 36 is negative 72. 24 times 6 is 144. Bring down your minus 70. So negative 72 plus 144 is a positive 72. Minus 70 is a positive 2. So our vertex here is going to be at 6, 2. And our graph is going to go down because it's negative. And it's going to be narrow because it's a whole number other than 1. And then for our x-intercepts, we're going to factor out a negative 2 to get x squared minus 12x plus 35. And then factor that out to get x minus 7, x minus 5. And then you will get a positive 7 and a positive 5 when you solve. So 7 and 5. So we're not going to be able to graph this one just because the numbers are so big. Look at that C value. So that one is not graphable just with the conditions we have right here. However, I still wanted you to have that practice of finding the vertex and such. So this is our last page of problems we're going to use for graphing. So first we'll find the vertex. A is negative 1, B is negative 6, C is 0. Just remember, you have ax squared plus bx plus c. A is always your number in front of the x squared, B is always the number in front of your x, and C is always the value without anything at all. So just remember those. So it's negative b over 2a, which gives us a positive 6 over a negative 2, which gives you a negative 3. And then we plug that number back into our original equation. So we have to do our exponents first. Negative 3 squared is going to give us a positive 9. Bring your negative down. And then negative 6 times negative 3 is a positive 18. So that's negative 9 plus 18 is a positive 9. So our vertex is at negative 3, positive 9. Our graph is going to face down, and it's going to be the same as the graph f of x equals x squared because it's a 1. Our y-intercept is 0. Since there is no value there, we state it's a 0. And then to find our x-intercepts, we have to factor. Remember we said that we had to take out our greatest common factor. If it's a negative right here, we have to take out that negative 1, which changes the sign of every term. So that becomes a plus 6x. Now we factor. You can pull out an x as well, and you can be left with an x plus 6. So we actually should have taken out a negative 1x, but we still got the same answer. So we're going to take our x and set it equal to 0, and our x plus 6 and set it equal to 0, and then solve. So our x-intercepts here are going to be a 0 and a negative 6. So the first thing we're going to do is plot our vertex. It doesn't matter which method you're going to use, you're going to plot your vertex first. So I've got negative 3, 9. So I'm going to start here, and I'm going to go 3 left because it's a negative. And I'm going to go 9 up. Okay, so that right there is my vertex. And I'm going to draw my axis of symmetry just because it seems to help you guys know where to go. Then you can use your x-intercepts, which would simply be at x equals 0, which is at the origin, and at x equals negative 6. So you could do it that way. and then you're finished. You just have to draw your curves and do your arrows at the end, and you'll be done. Or you could use your counting method, which your y-intercept would be 0. So we would count 1, 2, 3. You would count again 1, 2, 3. So actually, regardless of which method you use, you would still get the same points. And there's your graph. And you can always check and make sure that you did graph it correctly. Since it says that it's supposed to be down, make sure that your graph is in fact pointing down, okay? You'll need to make sure that you do have that, okay? That's why we have to find what A does so we know we can check ourselves. All right, final problem. So identify your A, B, and C to find your vertex. A is -1, B is -4, C is -3. So I've got -b over 2a. So opposite of -4 is 4. 2 times -1 is -2. And then 4 divided by -2 is -2. So then we plug that back into our equation. Do your exponents first. So -2 squared is just a +4. Bring down your negative. -4 times -2 is a +8. Bring down your -3. So -4 plus 8 is a +4. And 4 minus 3 is 1. So your vertex is at -2, 1. Our graph is going to face down, and it will be the same as the graph f of x equals x squared because that's a 1. Our y-intercept is -3. And then we are going to factor this in order to find our intercepts. So we take out that -1, which we should be used to by now. And then we factor. So I have x plus 3, x plus 1. Set them both equal to 0. And then solve. So we've got a -3 and a -1 for our intercepts. Okay? So our vertex was at -2, +1. So we would start at our origin and go 2 spaces to the left, 1 space up. All right, and let's use our x-intercepts. So if we use our x-intercept of -1 and -3, then you'll notice that if you look at your axis of symmetry, then they're both just 1 space away from it, okay? Or if you used your y-intercept method, y-intercept was -3. So if we go down to 1, 2, 3, -3 here, we would count. So we would go 2 spaces to get to our axis of symmetry, so we'll go 2 spaces to get to our other point. So that's going to make a pretty nice graph. Make sure you connect your dots. You do not have to use both ways. It's good to check yourself, but you only have to use one method in order to graph. I have to have at least 3 points, your vertex, and then 1 point on each side in order for me to accept your graph. So that's the end of this video. I hope that this has helped you, and I wish you the best of luck.